Good afternoon, students. Last classல நம்ம errors எப்படி calculate பண்றது? Okay. So what is the types of errors? இதெல்லாம் பார்த்தோம். So இதுல 2 more problems is left. So அந்த problems இப்ப நம்ம classல work out பண்ண போறோம். Okay. So first problem. In an experiment, four quantities A, B, C, D are measured with percentage error. Error that is 1%, 2%, and 3%, and 4% respectively. The quantity P is calculated as follows. That is P is equal to A cube B square divided by C into D. CD or measured with percentage error. Measured with percentage error. Okay. That is 1%, 2%, 3%, and 4% respectively. The quantity P is calculated as follows. That is P is equal to A cube B square divided by CD. Okay. So this is the given quantity. Okay. So now calculate the percentage error of this one. Okay. So now tell me the formula for percentage error. First, என்ன எழுத போறோம்? It is a formula for percentage error. Okay. Percentage error of formulation, that is anything, that is del x by x, which is multiplied by 100. So this is the formula for percentage error. So now in this problem, we are calculating the percentage error of P. Percentage error in the quantity, that is P. Okay. So P is equal to A cube B square divided by C into D. So this is the given value. Okay. So this given values, we can convert it into del x form. Okay. So far we are writing the differentiation values, that is del P by P into 100, which should be is equal to. Okay. So now differentiate this each values. Okay. A cube value, B square value, CD values. Okay. Keep in mind that here error values, Okay, error values தான் calculate பண்ண போறோம். Error values calculate பண்ணும்போது multiplication, division எந்த values இருந்தாலும் சரி அதை நம்ம add தான் பண்ணிக்க போறோம். Okay, right. So இந்த coefficient எல்லாமே என்ன பண்ணுங்க, just முன்னாடி கொண்டு வந்துருங்க. Okay, so 3 2 1 1. Okay, so now formula substitute பண்ண போறோம். So substitute பண்ணோம் அப்படின்னா a cube என்னவா convert ஆகும் அப்படின்னா 3 into delta a divide by a plus இந்த b cube என்னவா convert ஆகும் 2 into delta b divide by b plus multiplication, division எந்த values இருந்தாலும் நம்ம errors add தான் பண்ண போறோம்னு சொல்லியிருக்கோம். So divisionல இருக்கிற இந்த cd நம்ம எப்படி எழுதுறோம் percentage error ஓட formulasல, that is delta c divide by c plus delta d divide by d, okay, into 100. So this is the formula. Okay, so this formula is applied for the percentage error. Okay, so now let us now substitute all the values here. Okay, so here it is 3 3, and for delta a by a, okay, delta a by a, they are given 1%. Delta a by a is equal to 1% value. Okay, delta a by a value is equal to 1. That is, it is 1%. Sorry. Three into 1% plus 2 into 2%, and here delta c by c it is 1%. Okay, and it is multiplied, no, right? Then 2 by 2 into 4%. That is 1% into plus 4. Okay, so by calculating all these values, we are getting 14%. So that is option C is the right one. Okay, next problem. Problem number 2. Yes, very good. The option C is the right one. Percentage errors. Percentage errors in the measurement of mass and speed. Mass and speed are 2% and 3% respectively. Okay, then the error in the estimate of kinetic energy. Kinetic energy obtained by measuring mass. Measuring mass and speed will be what? Okay. So here they are given the options, that is the A is equal to 8% and B is equal to 2% and C is equal to 12 and D is equal to 10%. Okay. So here also we are calculating the percentage errors. Okay. So first we have to write the formula. So first formula first given values number எழுதிட்டு next formulasல substitute பண்ணி answer calculate பண்றோம். Okay. So for formula, okay, delta x divided by x into 100. So this is the formula. Okay. So let us now written in the given values. Okay. So percentage error in mass is equal to 2%. Okay, right. Then percentage error in speed value is equal to 3%. Okay. So what is the formula for kinetic energy? Formula for kinetic energy. Formula for kinetic energy சொல்லுங்க பார்க்கலாம். What is it? Kinetic energy is equal to half into m into v square. Okay. Therefore, we are calculating the measurement of kinetic energy. Okay. Measurement of kinetic energy. So, delta kinetic energy divided by kinetic energy is equal to del m into 100. Okay. Into 100. And here also delta m divided by m, for it is mv square, no? Mv square ku first thing we are taking m. Okay. So delta m divided by m plus 2 into v square என்னவா convert ஆகும்? 2 into delta v divided by v. Okay. Right. So here they are given the mass value, that is m value should be is equal to 2%. Okay. Plus 2 into what is the value of delta v? It is 3%. Okay. So 2 plus 6, that is equal to 8%. So the given option A is the correct one. Okay. Option A is the correct one. So it is a very, very simplest problem. Okay. So இதுக்கு நீங்க formulas தெரிஞ்சா மட்டும்தான் நம்மளால என்ன பண்ண முடியும், இந்த problems work out பண்ண முடியும். Okay. So we know the formula for kinetic energy, potential energy. Okay. So these are all very, very important formulas. Okay. Right. Up to this clear? Okay, we can go for the next chapter. That is gravitation. Okay. Gravitation. So in this gravitation unit, we are expecting at least 2 questions. Okay. From the Kepler's law and law of gravitation and acceleration due to gravity and the gravitational potential energy and for gravitational potential and escape speed. Island we can expect minimum 2 questions. Okay, right. So first one, what is a Kepler's law? Okay. So Kepler giving 3 formulas. Okay, right. 3 laws. First one, law of orbits. Law of orbits. And second one, law of areas. Law of areas. And third one, law of periods. Okay, law of periods. So இதுல law of orbits la என்னென்ன important points இருக்கு and areas la என்னென்ன important points இருக்கு and law of periods la என்னென்ன important points இருக்கு அதோட related problems தான் இன்னைக்கு கிளாஸ்ல work out பண்றோம். Okay. So first one, law of orbits. Law of orbits. So already we are known that in our solar system, we are having a central mass that is the sun. Okay. And here various planets. Okay. Various planets are revolving around the sun in a elliptical orbit. Okay. So that is the first law. So in first law, so this is our sun and this is our various planets. Here I can put it only one planet. So now, how many planets are there in our solar system, children? So put it in the comment box. Yes. It is 8 or 9. Okay, it is 8. So in this law of orbits, we can have our sun is at our one of the focus, and the planets, okay, the planets revolved around in elliptical orbit. Okay, let us now consider this one. Okay, suppose the distance between the planet and sun, if it is in a closed surface, means we are call it as perihelion. Okay, so the distance between planet and sun. Okay, planets and sun, it should be nearest. Nearest means we can having the closest distance. We can call it as a perihelion. What is the name? That is perihelion. Okay. Then the furthest distance or longest distance, we can call it as a aphelion. A-P-H-E-I-O-N. Aphelion. Okay. So based on the distance, what is the distance between the planet and sun? Here P represents the planet and S represents the sun. Okay. So the distance between the sun and the planet, it should be very close, means we can represent it the name by the smallest distances, that is perihelion. If it is in a far longest distance, means it is aphelion. Okay, aphelion. So that is the point you should know compulsorily. Okay. So from the first law of orbits, second one, law of areas. Law of areas. Okay. So law of areas la very important point, that is aerial velocity. Okay. Aerial velocity of the planets around the sun is constant. Around the sun, yes, constant. Okay. Suppose if you are having, so this is our elliptical orbit, and here our sun is there. Okay. And here planet is there. Okay. So if you calculating the areas, okay, if you are calculating the areas at the time of revolution, okay, the aerial velocity between the sun and the planet, it should be in a constant. Okay. At the time of revolution, The aerial velocity is the constant one. Okay, that is simply we can say that equal areas are covered in equal interval of time. Equal areas are covered in equal intervals of time. Okay, so simply we are written in a equation form, that is dA by dt is equal to constant. Okay, sometimes they are given the relation, that is delta A by del T is equal to constant. Okay, so in that problems they are asking the aerial velocity of the planets around the sun. Yes, options are constant, it is 0, it is maximum or minimum. In the options, there are 4 options they are given. Okay, so for we are known the relation. Okay, in the relations தெரிஞ்சா மட்டும்தான் அந்த questions க்கு நம்மளால answer பண்ண முடியும். Okay, so aerial velocity of the planets around the sun is always constant. Okay, keep in mind that. So this is the equation form, that is delta A by delta T is equal to constant. Next one. Here, angular momentum is also a constant one. So angular momentum. Angular momentum is, which is also equal to constant. So what is the relation for angular momentum? That is L is equal to R cross P. L is equal to R cross P. Okay. So simply substitute P is equal to M into V into R. Okay. So M into V. P is equal to M into V. Okay. Let us now put it in the formula, that is L is equal to R into M into V. So readily MVR is equal to L. So this is the very, very famous equation for angular momentum. Okay. So angular momentum, which should be in a constant form. So dA by dt is equal to L by 2m. So this is also one conclusion of the relation from the second law. Okay, so delta A divided by delta T is equal to L by 2m. Okay, so here L represented what? It is an angular momentum. Okay, angular momentum. Next, third one. So from this relation, we have one conclusion, that is we can relate velocity. Okay, velocity and radius. How it varies between planets and sun. Planets and sun. Okay, right. So suppose if you are considering this one as a sun, Okay, so this one is our planet, any one of the planet. Okay, so the distance, it should be in a closed form. Okay, closed form or nearest form. Nearest form means a velocity. Velocity will be maximum. Maximum. Velocity will be maximum. Okay. Suppose it is the longest distance. Okay. Longest distance or furthest distance means velocity will be minimum. So simply we can say that it is a sun and it is our planet. Okay. So it is revolving around the sun in an elliptical orbit. So if it is nearer to the surface, okay, it is nearer to the surface of the sun, the velocity will be maximum. Say for our consideration, in the part lerunde, that is the blue part lerunde, we can expect the maximum velocity. Okay. So in the opposite part, it will move very slower. Okay. So from the blue part, we can expect the velocity will be maximum, and for the yellow part, the velocity will be minimum. So V is maximum and here V is minimum. Okay. So what about the radius? Radius will be maximum. Radius will be maximum if it is near or far. Put it in the comment box. Here planet and the sun, yes, near the surface. Okay, near the surface means the maximum radius will be minimum. Okay, radius will be minimum. Okay, it is a farthest distance, the radius will be maximum. Okay, the radius will be maximum. So this is a simple logic. Okay, பக்கத்துல வரும்போது it will rotate fast. Automatically radius value should be minimum. Okay, so it is interrelated. Velocity maximum இருந்தது அப்படின்னா radius ஓட values கம்மியா இருக்கும். Okay. So இதை relate பண்றதுக்கு we can have one simple example, simple equations. Okay. So here from the second law, we are known that the angular momentum, which should be in a constant. Okay. So previously we are writing the relation that is L is equal to what? L is equal to M into V into R. So here M into V into R is equal to constant. Here also it is a constant. Now we are taking the difference between the velocity and radius. Velocity and radius. Okay. So let us now M into A and V into A and R into A. So this is for our first one, A part, and this is for the B, object B, that is dB into RB. Okay. Now our consideration is only for velocity and radius. So we can take it that unit alone. Adha mattum nama eduthukom, velocity and radius. Okay, velocity here V and here it is R, and VB into RB. Then we can relate VA by VB is equal to V, that is RB divided by RA. Okay. So this is our conclusion. Okay. So from that we can conclude that velocity is inversely proportional to R. Velocity is inversely proportional to R. Simply we can say that velocity is maximum. Abdina, radius is minimum. Okay, velocity is maximum means simply radius is minimum. Okay. So in the formula, it is a very, very important formula. In the formulas, நம்ம நிறைய sums நம்ம work out பண்ண போறோம். Okay. So இதுல இருந்து problem கேட்கக்கூடிய formula இந்த second law ல இருந்து, that is VA by VB is equal to RB by RA. And one more concept, that is velocity and radius is interrelated. Interrelated means velocity increases and radius decreases. In the concept ஞாபகம் வச்சுக்கணும். Okay. Next one, laws of period. Okay, third one, laws of period. Okay. So it is a very, very important law. Kepler's third law is very, very important. Okay. So what is the statement? The square of time period. The square of time period of the planets revolve around the sun. Revolve around the sun. Yes. Directly proportional. Directly proportional to the cube of the semi-major axis. Semi-major axis of the elliptical orbit of the planet. So this is our statement. Okay, that is Kepler's third law. Okay, it is a very, very important one. We should know the statement also. Statement compulsory தெரிஞ்சிருக்கணும். Okay, so statementல இருந்ததா நம்ம சிம்பிளா ஃபார்முலாவை எழுத போறோம். Okay, so the square of the time period of the planets revolved around the sun. Time period, yes, denoted by the symbol that is T, and it is directly proportional to the cube of the semi-major axis. Okay, cube of the semi-major axis mother, we can put A or R. Cube. Okay, right. So simply we can take it the semi-major axis, that is A or T, which is proportional to R cube. So here they are given the square, no? So it is T square. Okay. So the famous equation, that is T square, which is proportional to R cube. Okay, which is proportional to R cube. So this is the formula we are frequently used in the problems. Okay, used in the problems. So what is the formula we are getting from the third law? That is T square, which is proportional to R cube, or simply T is proportional to R power of 3 by 2. R power of 3 by 2. So this is also correct. This is also correct one. Okay. Then next we can go for the simple problems. Okay, simple and frequently asked problems. So problem number 1. A planet moving along an elliptical orbit. Elliptical orbit, yes, closed to the sun. Closed to the sun at a distance. At a distance R1 and furthest away at a distance R2 if V1 and V2 are the linear velocities. Velocities at these points, respectively. Then the ratio of V1 by V2 is what? So this is the question. So the given options are R1 divided by R2 the whole square, and for B it is R2 divided by R1, and for C it is R2 divided by R1 the whole square, and for D it is R1 divided by R2. Okay, so the options C, it is R2. Okay, R2 divided by R1. So now tell me the answer. Which one is correct? Yes, it is the option B. How you will be say that the option B will be right? So ipadan paathom previously we have derived the formula for the relation between VA that is VA by VB is equal to RB by RA. Okay, right. So from the second law, we are having the answer. This is from the second law. Okay. So இந்த மாதிரி problems ரொம்ப பெருசா இருந்தாலும் நம்ம சிம்பிளா லாஜிக்ஸ் தெரிஞ்சிருக்கணும் பிளஸ் அதுல இம்பார்ட்டன்ட் பாயிண்ட்ஸ் தெரிஞ்சிருக்கணும். தெரிஞ்சது அப்படின்னா ஃபார்முலாஸ்ல தான் இருந்து சப்ஸ்டியூட் பண்ற மாதிரி இருக்கும். ஓகே, ஸோ ஃபார்முலாஸ்ல போட்டோம் அப்படின்னா நம்மளால ஈஸியா ஆன்சர் பண்ண முடியும். ஓகே, let us now go for the second one. So keep in mind that here it is A, here it is A na radius will be B. Okay, so here it is B abdina radius will be A. Okay, so V1 by V2 abdina answer automatically reverse R2 divide by R1. So this is the correct one. Okay, next second problem. The period of revolution. The period of revolution of planet A. Planet A around the sun. Around the sun later than that of B. B from the sun. So this is the question. The given options are 4, and for B it is 5, and for C it is 2, and for D it is 3. Okay, how to calculate this one? The period of revolution. So in that problem they are asking the period of revolution they are given. Okay, so from the previous period of revolution away we can readily go for the Kepler's third law. Okay, Kepler's third law. So let us now solve. So solution. Here the period of revolution, period of revolution of planet A, we are take it as a TA, that is the time period which should be is equal to how much time? The period of revolution of planet A around the sun is 8 times that of B. Okay, 8 times that of B na you put it 8 into TB. Okay, into TB. Now, let us now take an Kepler's third law. Kepler's third law. So what is the statement? That is the what is the formula? That is T square, which is proportional to R cube. Okay, so simply we are writing RA by RB the whole cube. Okay, the whole cube is equal to TA by TB the whole square. So this is the formula. So in the formula, we have to substitute for TA. So TA values, it is 8 into TB. Okay. So now substitute 8 into TB divide by TB. So TB values, it should be cancelled. Okay. So 8 square. Here 8 square. So RA by RB, the whole cube is equal to 8 into 8. 8 into 8, it should be 64. Okay. So now RA by RB is equal to, okay, 64, the whole power 1 by 3. And here it is 4 cube into 1 by 3. 3 cancelled. Okay. So RA by RB is equal to, it is 4. So in the simply we have to write RA value should be 4 into RB. Okay, 4 into RB. So this is the result. The option it is option A. Okay, so it is option A. How many times it is greater? It is 4 times. Okay. So the option A is the correct one. It is easier follow பண்ண முடியுதா? Comment box ல போடுங்க பார்க்கலாம். Next, problem number 3. Yes. Yep. Satellite of mass m, yes, at a distance of r from the surface of the earth. Another satellite B of mass 2m, yes, at a distance of 2r from the earth's surface, earth's center. The time periods are in the ratio of what? Okay, so here they are given the options, that is 1:2, and for B it is 1:16, and for C it is 1:32, and for D it is 1:2 into √2. Okay, right. So here we noticed that your satellite of mass m is at a distance r. at a distance r from the surface of the earth, and another satellite B of mass 2m. Okay, so mass 2m, here it is m, and the distance here it is a, and here it is 2r. Okay, from the earth center, their time periods are in the ratio. Okay, let us now try this one. In the formulas solve பண்றதுக்கு we are taking Kepler's third law. Okay, so solution, the time period, keep in mind that the time period does not depends on mass. Okay, time period does not depend on the mass. So அதனால இதுல mass ஓட values நம்ம calculations எடுத்துக்க போறது இல்ல. Okay, so from the Kepler's law, we are taking the relation that is t square, which is proportional to r cube. Okay, right? So here we are having planet A and planet B. Okay, so first one having a distance r and mass m. So simply we are written as RA. Okay, and here they are given 2r and 2m. Here the radius value, take it as RB. Okay, let us now substitute in this equation. That is TA by TB, the whole square, is equal to RA divided by RB, the whole cube. Okay, so satellite 1 and 2 க்கு formulas நம்ம rearrange பண்ணி எழுதியாச்சு. Next one, we have to substitute the value for RA and RB. Okay, for RA it is R, and for RB it is 2R. Okay, so that we have to substitute in this one. So R divided by 2R. Okay, so the whole power, now we can rearrange the formula also. That is TA by TB. TA by TB, which should be is equal to, here it is cube, no? Cube. The square, it should be reverse now, it is 1 by 2. So readily I can write it the formulation, that is R power 3 by 2 divided by 2 power R into 3 by 2. Okay, so simple. இங்க இருக்கிற ஸ்கொயர் ஃபார்முலேஷன் என்னவா கன்வெர்ட் ஆயிருக்கு, இங்க 3 by 2 வா கன்வெர்ட் ஆயிருக்கு. ஓகே, next we can split it this terms. R power 3 by 2 divided by 2 power of 3 by 2 into R power of 3 by 2. Okay, R power of 3 by 2. So r power 3 by 2 divided by 2 power of 3 by 2 into r power of 3 by 2. So simply we cancel this r power 3 by 2 and this r power 3 by 2. So here we are having 1 divided by 2 power of 3 by 2. Okay. So is again 2 power of 3 by 2. It is splitted into 2 power of 1 into 2 power of half. Okay. 3 by 2 where how we can split 1 into 1 by 2. Okay. That is 3 by 2 means it is 1 and a half. Okay. 1 and a half. Right. Then again we can split it into 2 into 2 power half. We can write it as a root 2. Okay, root 2. So here from the left side, we are having TA by TB. Okay, so therefore, TA by TB is equal to 1 divided by 2 into root 2. So therefore, it is the ratio that is 1 is to 2 into root 2. So this is our conclusion. Okay. So the option D is the correct one. Option D is the correct one. Okay. Yes. Next, we can go for the next problem. That is problem number 4. Yeah, geostationary satellite. Satellite, yes, orbiting the Earth. Orbiting the Earth at a height of 5 or above that surface of Earth. Earth, then or being the radius of the Earth. The time period of another satellite in hours, at a height of 2 or from the surface of Earth. Yes. Options are 5, B it is 10, and for C it is 6 into root 2, and for D it is 6 by root 2. Okay. How to solve this one? Problems that it is paakradhukku, it should be very large, but the solution should be very easy, children. Okay, let us now solve. So keep in mind that they are given the values 5R and R. Okay. So for the solution of this question, from the third law, from the Kepler's third law, we are writing T, which is T square is proportional to R cube, or T, which should be is equal to R power 3 by 2. Okay, right? Here they are asking the time, no? So we are writing T2. They are asking T2, no? So T2 divided by T1 is equal to R2 divided by R1, the whole power 3 by 2. Okay. So read out the problems. It is carefully. A geostationary satellite is orbiting the Earth at the height of 5R above the surface of the Earth. Above the surface. Then R be the radius of the Earth. We have to add this R. Radius or values we have to add. So we can write it the value that is R plus 2R. Divide by, for R1, it is R plus 5R. Okay, the whole power 3 by 2. So let us now adding the value that is here, it is 3R divided by 6R. Okay, the whole power 3 by 2. So this is 1 time and this is 2 times. So 1 by 2, the whole power 3 by 2. Okay. So let us now 2 power of 3 by 2. And 2 power of 3 by 2 again split it into 2 into 1 power half. And again 2 into root 2. Okay, 2 into root 2. So they are asking the time period, no? So in that problem, they are mentioned it in a hours. So hours we have to calculate. Okay. So since we are taking the value T1 is equal to 24 hours. How many hours in a day? That is 24 hours. Okay. So here we can have T2 by T1 is equal to, okay, 1 by 2 into root 2. Okay. So this values we are having up to this. Okay. So இதுவரையில நம்ம என்ன solve பண்ணிருக்கோம்? T2 divided by T1 is equal to 1 divided by 2 into root 2. T2 divided by T1 is equal to 1 divided by 2 power of 3 by 2. Okay. So we need only T2 value. So the T1 divided by 2 root 2. So simply you are writing either 2 power 3 by 2 or 2 into root 2. எதுனாலும் நமக்கு correct தான். Okay. So here T1 value is 24 hours. Okay. So put it 24 divided by 2 into root 2. Okay. 2 into root 2. Now cancel this one. Okay. One time it is 12. Okay. 12 by root 2. So answer la check பண்ணுங்க. Is there any 12 by root 2? No. So multiplied and divide by root 2. Okay, multiplied and divide by root 2. So this value becomes 12 into root 2. Divide by root 2 into root 2, it is 2. Okay, then for the next step, we cancel this one, that is 6 into root 2. So therefore, the value T2 is equal to 6 into root 2 hours is the correct one. Okay. So this is option. This is option C. Yes. So இந்த மாதிரி different kinds of problems கொடுத்துட்டு நம்மளுக்கு solve பண்ண சொல்வாங்க. So இன்னைக்கு solve பண்ண equations and solutions எல்லாமே நம்மளோட Kepler's ஓட third lawல இருந்து நம்ம derive பண்ணிருக்கோம். Okay. So one more problems is there. So this should be discussed in the next class. Okay. Up to this clear, children? எல்லாராலையும் இந்த problems வந்து attend பண்ண முடியுமா? Put it in the comment box. Yes, thank you. So இதுல நம்ம ஒண்ணே ஒண்ணுதான் பண்ணணும். என்ன பண்ணணும் அப்படின்னா daily formulas தான் நம்ம என்னென்ன substitute பண்றோமோ அந்த formulas we have to thorough. Okay, formulas thorough பண்ணிக்கணும். என்னென்ன logics யூஸ் பண்றோம் அப்படின்றத மைண்ட்ல வச்சுக்கணும். Plus class நடத்துறப்போ நம்ம hints எடுத்துக்கணும். ஓகே, என்னென்ன இம்பார்ட்டன்ஸ் பாயிண்ட்ஸ் சொல்றாங்க பிளஸ் சம்ஸ் சொல்றாங்க, அதுக்கு ரிலவெண்டா இருக்கிற ஃபார்முலாஸ நம்ம நல்லா நோட் பண்ணி வச்சிட்டோம் அப்படின்னாவே we get good marks. Okay, thank you children, meet you on tomorrow.